Morning. All right, so this video is going to be about completing the square. And completing the square is going to be the next process that we're going to talk about in this unit. The idea here is that with completing the square, we want to convert an equation of a parabola from standard form to vertex form. All right, there's a number of reasons why we might want to do this. One of which might be just that it's easier to graph the parabola when it's in vertex form than when it's in standard form. In vertex form, the vertex appears right in the equation itself. So we're going to talk about this process. Now this process is a very step-by-step detailed process. And so as you're writing down these notes, I would make sure you write down each individual step as we go. I'm going to use this as an example to follow this, so I'd encourage you to have a piece of paper, write these steps out, write everything that I write down, and use that as a guide for when you attempt problems like this on your own. All right, so we're starting with this equation, y equals x squared plus 6x minus 5. This is in standard form. Recall that here's our y-intercept, the c term. All right, so our y-intercept is -5. So the first thing I'm going to do is I'm going to rewrite this equation, but I'm going to leave a space between the 6x and the -5. So all I'm going to do is I'm going to rewrite it. Y equals x squared plus 6x, and I'm going to slide the -5 over. Okay, that's the first thing you need to do. And what we're doing is we're going to leave a space here, and I'm also going to draw an underlined space right here. Okay, we're going to have two blank spaces. And what we're going to do is we're going to add some constant in here, and we're going to subtract that same constant over here. Now, sometimes you can add the constant here and add it to the other side of the equation. We're going to add it and subtract it on the same side of the equation, but that would be equivalent to adding it on both sides of the equation. You might see in the delta math problems that they ask you to do it that way, where you add it on one side and also add it on the other side. So here's the most important step of completing the square. You have to figure out what the constant is that you're going to add into this space. And the idea is we want to add some constant such that this forms a perfect square. All right? We need this to form a perfect square. Okay? And if you recall what perfect squares are from the previous video, perfect squares are values that half of the b term squared is equal to the c term. Okay, I'm going to write that out. The c term is equal to half of the b term squared. Okay, so we need the c term to be equal to half the b term squared. So to figure out the c term here, this is the c term right here, that's going to be the piece, the constant that we're adding in. So we're going to take half of the b term, which in this case is 6, and we're going to take half of it, and we're going to square it. Okay, so half of 6 is 3, 3 squared is 9. 9 is our constant that we're adding and subtracting on the same side of the equation. So that's going to go here, and that's going to go here. Okay, so we're adding 9, and we're subtracting 9. And again, the reason we did this is because now this quantity is a perfect square, x squared plus 6x plus 9. We have these leftovers over here. We're going to get to those in a minute, but let's talk about this perfect square. This is called a perfect square trinomial, which now we can write as a perfect square, or as a binomial squared. So, to write this as a binomial squared, you're just going to factor this. Okay, x squared plus 6x plus 9 factors to be x plus 3. Now when we factor this, it's always going to be half of the b term, half of the 6. That's going to be this piece that's in the parentheses here. All right, so now we have the perfect square is written as x plus 3 quantity squared. And you just got to look at what do we have left over. We have the minus 5 minus 9 for a total of minus 14 left over. So what we've done is we've converted the original standard form parabola into a vertex form parabola. And now we know that the vertex here is going to be negative 3 comma negative 14. Okay.